Hello everyone. In today's video, I'm going to discuss about new CM5 IO board and I'm going to cover everything as possible regarding this board. So what I will do in this video is I will open the design files of this circuit board and I will explain all of the circuitry and the modification you can done to get draw on customized CM5 board. If you are thinking about designing a CM5 baseboard for your project, this is the video for you. Okay, let's start. First thing, what I did was actually I went to the Raspberry Pi website and I got the CM5 IO board high-tech file. So then I opened it actually come as a zip folder, then unzip it, and you can open this file using the keypad. So once it is open, it will look like this. Once you open the schematic, it will look like this. And the PCB is like this. And the 3D view is this. Awesome, right? So very interesting. Pretty much similar to the CM4 board. However, there are some differences. Let's discuss about the changes from CM4 and what we can do, what are the changes, this kind of thing. Okay, now let's just start up with the root page. So this is the schematic and I will zoom up for you. So in the root page, you can see there's a Type-C connector and USB power is coming and the high-speed section is on the page 2 and the GPIO Ethernet on this page 3 section and PCIe M.2 is in this section. So you can see the USB signals are going to the high speed section, which is this USB port is basically to power this board and also the flash the image to the module and also can work as a host like the USB OTG, which is very interesting. And these are signals going for the PCI Express M.2 port. And one important thing is this PCI M.2 port is like only PCI Express signals connected. And somehow some PCI like M.2 ports use USB signals, but this is PCI signals are connected. So some modules like LTE modules kind of thing, although they come as a M.2 form factor, like if you plug that kind of module which are expecting only the USB signal will not work in this port, which is something to remove. And this page, we have Ethernet circuitry, and interesting thing is the CC lines from the USB Type-C is controlled by the module this time, like in the CM4 as I remember, they are not controlled by the module. So this is to this is to this CC pulse control actually helpful in like putting to the host mode, like OTG mode, slave mode, and also like power management in Type C. So they are controlled by CM5. You can see they are connected to the CM5 in this inside this page once we open. Okay. Now to make the understanding easy, so what I did was actually I prepared an agenda to discuss further, which should be easy to follow. So what I will do is like I will discuss about the power side first, and then we'll go to the high speed peripherals, which is the second page of the schematic, and then we will go to the third page of the schematic about the GPIO and Ethernet, and the fourth page of the schematic is the M.2 port, and I will discuss about the M.2 port there and then we will discuss about getting our own PCB, like modifying it, what we can do, kind of things, and finally, like how to manufacture that our own CM5 customers board. So in the power side, I'm going to jump into topic one, and in the topic one, let's go to topic one and see what we got. So In topic one, we are going to discuss about power supply requirement, like what kind of power supply we can use with this board, and then power sequencing, which is quite important, and some power related input things, power related important things. Okay, so jumping to the schematic. Actually, there is no separated power supply page in this schematic. So the power is all about here in this board. In previous CM4 IO board, they had included the 9 volt to 28 volt kind of input. Like we could use a power jack in the board and provide like 9 volt or something like higher voltage to that board. But in this board, they did not have included that. So the only option to power board is the Type C connector. So you should use a Type C at least 2 ampere power supply with this board. So if we go to the 3D view, you can see we do not have any other power input. The only option is USB port. So you should only provide 5 volt to the module with this board. What if you want a customized board of this one with the capability of providing 12 volt, for example? What you can do? Okay, it is not very complex. What you can do is you can simply look into the CM4, not CM5, but CM4 IO board, and they have a buck converter there. You can use the same design here and add some sort of power switching in between type C and uh, other power input when your both are available. So you should only use one. At the power switching circuit and or power selectizing, and then you can you can get your own modified board which can work with 12 volt ports. Or that is one thing you can do. Mm, it's not very complex stuff. What I will advise you to do is like what you can simply do is you can download the CM4 IO board files and you can use that same power supply if it works for you. Then add into the board and modify that circuitry and do the PCB design. Okay. All right. So regarding the power supply we can use is type C. Only 5 volt and like to at least 2 ampere. And then we will go to the power sequence. For that we need the data sheet of this board. So the data sheet here I downloaded data sheet. Let me open it. I have already opened the power sequence. So in the power sequencing, it says this required 5 volt supply and it already have integrated 3.3 volt and 1.8 volt output, which is very useful because uh, most like even though we supply 5 volt to this IO board, the GPIOs of this board works at either 3.3 volt or 1.8. What you can do is you can use this jumper to select which voltage the GPIOs will apply. Let's say, for example, you are designing a CM5 board with ICs or with some kind of sensors connecting to the CM5, which are working with 1.8 volt. So you do not want to use the converters every time. What you can do is you can select the GPIO reference voltage as 1.8 volt by mounting the R4 here and removing the R5 here. Then your system voltage is 1.8. But in default, in this design, you can see the default voltage 3.3 volt. So in this board, the default board, the GPIO reference is 3.0. So they are operating at 3.0. So uh, these 3.3 volt and 1.8 volt actually comes from the module itself. We do not have to add extra voltage regulator. You can see here we have two outputs. Each can provide 600 milliampere, which is very good value. So do not have to add an extra 3.3 volt or 1.8 volt regulator in your circuit. So that is good thing to remember in your design. Okay, let's go to the we work in power sequencing and how power is turned on in this manner. At first, we provide the firewall to the system, and we here we have a very important thing, which is PMIC enabled, which stands for the PMIC means Power Management Integrated Circuit. So PMIC enabled pin, I want to discuss about that. So if you put that PMIC enable pin here, I will show you. Here we have PMIC enable pin. If you put that pin into the high, module power management circuit will work, like that will get enabled. If you put that pin into the low, the power management IC will disable, then module will not power on. So by default, that pin has a pull-up resistance. So you don't have to worry about that connecting it to the another pull-up or something like that. It is already pull-up inside. But if you want to control the spin, you can pull it down using some kind of switch or something like that and control the power management circuit of the mobile, which is very good feature. And it is good to know that we can control the module power supply. So in some cases, we want to save the power, and this is a good way to enable and disable the power of the module. And another option, I saw we didn't have in CM4, but we have in CM5 at my memory, the power button. So the power button here is a switch. We can connect again if you connect a push button in between ground and power button pin. The power button pin is here. So the power button, what happens is that we can use this push button. Let's say, for example, module is in sleep. If you short press this, module will get on. If you long press and hold this, you can use the same button for shut down the module. So which is very handy feature, and make sure that when you are designing your own customized board, you to use this pin and connect to a push button, which will be very helpful in your design and testing kind of things, which will be very helpful. So actually regarding the power side, this is pretty much I have discussed. But if you have any question in mind, you can put in comments so I can answer. All right. So now I'm thinking about moving to the, so we were pretty much in the root phase right now because the power is here, the power circuit is here. And now I'm going to move into the high speed check in the circuit. Okay, so in the high speed section, let's see what we have discussed. All right. In the high speed section, we have DSI, CSI port, HDMI port, and USB 3 port, not USB 2. In all CM4, we only had USB 2, but now we got USB 3. Good. See, we are moving to the schematic. Now, this is the CM5 module, and the signals coming from CM5 module is listed here. Actually, and let's move to the DSI, CSI connector, display camera connector. So we got two connectors here, and these are uh, signals and clock. like the differential pairs, and data signals and clock signals of the USI or CSI, and some GPIO connection, and one important is like 3.3 volt supply is provided to this board, and also I2C, which is very important to communicate with the connected device. So let's say, for example, if camera is connected to this board, this I2C is used to communicate in between CM4 and so CM5 and the camera. So like sending instructions, settings, configuration of the camera, and reading the camera, configurations kind of things, like this I2C is used for that. So important thing regarding this DSI or CSI 1 port, not the 0 port, but the 1 port. So what is important is here you can see these two lines actually. These two, like the I-star SCL1 and SCA1 is not directly connected to the module, but instead they are going through a jumper here. So if you are using DSI1 or CSI1, you should fit the jumper. Or if you are going to design a custom board, um, what most people are doing is taking this design, sometimes delete the rest of thing you do not want and just modify that. Yeah, most of people are doing so. But one thing to remember is if you are using this port like the DSI1 or CSI1, you should not remove design. At least if you look what you can do is you can put the jumper here. Like you can remove this jumper and directly connect, but should not forget to add this part to your design. I mean, do not delete this part. Otherwise, this BSI one on this code will not work in your software. All right. Now I'm going to move to the USB 3. So this is very good news for I know uh, Raspberry Pi users. CM4 did not have USB 3, and I remember some customers came to me and asking for the USB 3, and what it did was like we were utilizing PCI Express signals, which had the with CM4. I'm speaking about CM4. Always got like which what we did was we converted the PCI Express into the USB using some ICs and then provided USB 3 port. But in CM5, we got two USB 3 port, which is very helpful for the people who need USB 3. And these are that USB ports. So in the USB 3, you know, in the USB 2, we only got USB data plugs and data minus. We only in USB 2 we only have this, but in USB 3 we have extra two differential pairs RX and TX, like this one here. So one important thing, like these signals are directly coming from CM5. So when you are adding USB 3 to your design, you don't have to worry much about. Like you can just directly connect these pins to your USB port, and that's it. But one important thing, they have one cool trick they have done is this. So if you see the RX negative uh, signal here and the positive signal is here, but the positive is like you can see connected, they are set. The RX minus is connected to the positive and positive is connected to the positive connected to negative. Like they should have connected like shown in my drawing, but they are set. But they still works because in the USB 3 there is a feature called polarity detection of this signal. So we do not have to worry about connecting Rx negative into the Rx negative. You can still swap and connect. Same applies for the TX. You can connect TX negative to the TX positive. Uh, Still, the USB 3 works. So this is done to simplify the USB like signal routing in the PCB. What happens is if you swap like this, the signals may get crossed when you are trying to route in the actual PCB. So in order to avoid that, what they have done is to simplify the routing, they have done this. It is not a rule you should follow the same like this one. Maybe you get a different USB connector and different orientation, like different placement in respect to the module. So what I want to mention is you can swap these as you want. That is good to know in your design. You can do the same for the other USB ports as well. So that is pretty much regarding USB 3 port. And one thing remains, the V bus, the voltage for the USB 3 port. So it is coming from the here. So 5 volts coming from USB Type C connector we connect come here. The 5 volt comes here, and this current limit switch which limit the current because what happen is, let's say for example, you are connecting directly this 5 volt like this to V bar. Let's say we are connecting like this. What happen is your system 5 volt directly connected to the USB port, which will still work in your board. But what if something goes wrong? Like you are connecting some malfunction USB device to your USB port, then if you start to go a large current, then whole the system power goes down, and it is not good for the design. And maybe whole the system can fail in. I mean, whole the hardware may get fail. So it is always good to limit the USB each USB port current because we never know what will user connects to these ports. What they have done is they have used single current limiting switch and using common V-bus for the both of these USB ports. But if you want, what happens is if one USB port goes wrong due to a large current or something like that, the other will also shut down. So if you want to prevent such a case, what you can do is you can use two limit switches. Like what you can use, you can take a copy of this and paste here, but adjust the value of this resistor. Like this resistor is for limiting the current. The based on the value is select here, the current varies, the output current varies. So we can change the value and then we can reduce the current for each port. All right. That is regarding the USB. And now let's come to the actual HDMI settings. Okay. In the HDMI, let's come into the power of the HDMI first. Here we have another IC here, which is from MOSFET. Actually, the reason for adding that is high side power switch actually. It is also capable of limiting the power. Um, and for this like what they have done is this power switch can limit the current to the HDMI. But they haven't directly connected the 5 volt to the HDMI 5 volt again because it is always good to put this kind of a limiting thing for the outside world connections because we never know when we are designing an IO board, people will connect various things. So uh, by connecting one malfunction or one bad device to the board, it is not good that all board get fail. So it is always good to put this kind of limiting things like we can sometimes use resettable fuses or power limiting switch like this or any kind of protection kind of things like they have done here. So they are again here using common output for the HDMI 5 out here and the HDMI signals here with clock signals. These are two clock signals and these are carrying the data of the video and these are again to communicate with through the I2C. I2C is using to get the display parameters and kind of things like for example display resolution and the connected display size kind of things. We can the size cards we can use to get such details and also hot plug is used to detect the once the device is plugged this pin inform the CM5 so CM5 start to transmit the data. CM5 start to communicate with the device and then transfer the video data to SDM. So HDMI, this support also the Sigma chain. It has separate signal coming from HDMI 1. Previous one was HDMI 0. So these are two full-size HDMI ports in this model, this IO board. All right, it's a long video, right? So I think you're pretty much clear about high-speed perception. Actually, I could, as my understanding, I could cover all schematic of this page. And now I'm thinking about moving to the next page. So before moving, um, let's go to the our agenda actually. What we are going to discuss. All right. So in this section, we are going to discuss about CM5 GPIO and GPIO boards and Ethernet circuit, and also some important things and also representation regarding. So move to the next page. Okay, this page. Let's zoom out and see what we got here. Okay, in this page, we got plain CM5 here, CM5, and lot of signals coming out from the CM5. And now let's start with the GPIO header. Okay, like all other Raspberry Pis, this got ported with the GPIO header. Actually, I'm not going to cover or what all of these things do and GPIO do. We are not going to explain, which you can find out on when there are a lot of in websites that will explain about this thing now. So I believe I couldn't have much time to double check everything, but I believe this pin out is pretty much similar to the CM4 algorithm. So, and the features would be same because it connects the device is connected to very well versus this portable header. So they are keeping this header as same as possible in this design. So one important thing as I previously mentioned, if you have a voltage selector, which is which will be very useful in your CM for CM5 or your customer's board design. So do not forget about the prepare reference voltage selection thing in your design. And next, move into the some important LEDs. Do not delete these from your, if you are designing a custom board, it is always good to keep these LEDs because it is easier to debug your board if something goes wrong, like this power LED and this active LED, which are helpful to identify what's happening in the body or what's happening in the board. So keep this small thing, but the value of those things are bigger than the space they are taking in their work. Okay. So we actually covered about the power button here, but one thing is the battery. We have CR2032 battery got here, so it is used to like power saving kind of RTC kind of thing in the CM5 module. And you can see that here. If you don't want it, you can in your board you can remove. And here we have a fan connector to like it is used like if the module get heated, this fan PWC module will place kind of like it is good to have this connector in your design to keep your board, especially to keep the CM5 cooler. So keep that if you are designing a board, it is always good to keep the fan connected. Otherwise, if you are doing a processing, when you are doing some processing, CM5 may get into that. It is not good. Then you should always keep the CM5 cool as possible. All right. Now I want to come into this header, which is very important header, and I'm going to discuss about each of these things and let's move to my slide. So, okay, let's discuss about one by one. So, first thing, actually, these signals connected directly to your model, like this one connected directly, so this one connected directly, and power management IC enable. I discussed earlier in the power section and power button. I also discussed this in the earlier power section, and but other than that, I am going to discuss about these four things in next few minutes. So let's discuss about the boot. So I'm going to discuss here like this because it is easier to follow. So this boot pins in the CM5 module is very useful when you are designing the IO board because once you design the IO board, you need to flash the image like you need to put the CM file into boot mode in order to flash the EMCC in the module. So if you do not use this signal or if you do not keep this signal accessible from your board, you will start to face some troubles once you want to flash the EMCC with the new image. So this pin by putting this pin to the low, I mean connect this pin to the ground like this, you can put the module into boot mode and then you can flash the EMCC of the CM5 using this type C port because you can see this type C port use these two signals are connected to the module like here. So mm, here. So it is very important to keep this boot pin accessible. Somehow you can connect it to a push button in between, like instead of jumper or something like that. You can keep this jumper in your board. And second thing I'm going to discuss about write protection pin of the EEP ROM. So what does this thing do is like it's the right protection. So it used to protect the EEPP ROM. So it is always good to keep that pin accessible. Or if you want to keep your EEP ROM right protected permanently in CM4 board, what you can do is instead of CM5 in the CM5 IO board, you can directly connect if you want permanently to be right protected, you can directly connect like this wire and that's it. Or it is recommended to use a zero ohm resistor instead of a wire. So anytime you can do a modification, like if you want to remove that connection, you can easily remove that zero in that case. So it's always recommended to use a zero ohm resistor in between instead of a wire like this. So, okay, now let's go into the sync output pin, which I haven't used much in any of the designs I have done, but what it does is, it is a kind of pin which is very useful in very high critical designs like it's it's a synchronizing clock in the network, so that pin provides some sort of a signal for the precise timing in the Ethernet network. So you can see this sync out is connected to the Ethernet sync out pin of the pin 18 of the module. And okay, now let's go to the USB OTG. The OTG pin is connected to here actually in the high speed page, pin number 101. What happened is the OTG pin can be used to, let me show you what is there. Actually, this pin is an input pin. So by putting this pin to low, the Raspberry Pi USB Type-C port can be converted into the USB host port. Let's say now you need a three USB port in your CM5 IO board. But when you look into the design, let's see here, you only have, now you can see you have two USB Type-C port and you only have USB, two USB port, only two USB port. But you need to connect three USB devices. So how you can do? So one thing you can do is, one thing obviously you can do is you can use USB hub sort of IC and expand it and get more USB. But other than that, a quick trick is use this USB Type C, and whenever you do not you want to class image or something like that, you can use this as a host USB, which means you can connect a mouse, pen drive, or kind of peripherals into that, and CM5 will like start to work as a host for that USB. So, in order to utilize that feature, you should use this OTGP. So, by as extend here, it is internally pulled up, which means a USB-C port or USB-C port is normally works as USB-5 normally works as a slave, but it can be used as a host mode if you pull down that pin. So it is very tricky and very useful in your designs when you need more than two USB ports. Okay, let's move into the. Okay, I think I covered this important configurable pins for and moving back to my slide. And I wanted to discuss about GPIO board. And okay, I covered it. Actually, I covered this one as well, which is the configuration pins. I just finished, and now I am going to discuss about Ethernet port. Okay, now let's see the internet code, that's the code, cool, right? Internet code, we got this one. Also, we got some USB protection here, and signals going to the module directly. So, module has the all the internet, no extra included, just the electrical internet uh, interface is there. But one very important, also we have the power over internet things here. So one important thing we have to discuss. Let's do should do kind of this is the kind of circuit. So in the Ethernet we have these two we got the protection for the Ethernet signals here, and this is the power over Ethernet header. So you know about power over Ethernet, right? We can take power the some like we can get 5 volts using some kind of power over Ethernet modules which are converting the uh, however, Ethernet to a firewall kind of things, we can use this header. But this board did not get power over Ethernet module. They have just provided the header. So if you need to you add the power over Ethernet to your customized CM5 board, what you can do is you can do something like that, power over Ethernet module. Firewall, let's say, so like that. So here we got some like something like that. Like 5 volts output, 1.8 ampere isolated PO module. So what you can do is you can here we have a good example. You can connect the uh, wires coming from the Ethernet like this and which provide the 5 volt to the Raspberry Pi. Like we have to add such kind of module or circuitry if you need power over Ethernet to this board. But this board does not have the power Ethernet module in this circuit, just the plug. So keep in mind. And these are protection. And this Ethernet jack actually include all the magnetics and kind of circuitry. Some people like you can't just connect the RJ45 without these magnetics. So let's say, for example, this connector, as my memory is not easily available in GPIO or somewhere, my memory I see it is available in mouse and not the says not available. So this is one challenge people experience when designing a custom board because the original for Ethernet board they have included is not available in most of like familiar with that like the GPM also. So you can use a different Ethernet board, of course, but make sure that the if it has the integrated transformers and kind of circuitry which need, or you can add transformer IC and design the circuit in the PCB and use the normal RJ45 socket. So that is about the internet. Other than that, it is pretty much straightforward. These signals are going directly to the CM5. And again, for the Ethernet routing, when you are routing the PCB, you should make sure that you are following the length machine and those things, which I will explain in the from in the PCB design. All right. Now, the last thing in this page is the SD card. So in the SD card again, first thing I know that is like they have connected the SD card power. They have provided an option to power on the SD card without just connecting directly power to the SD card. What they have done is they have added the power switch, so which is very handy. So they can turn on and off to the power to the SD card and save some power as well. So this port is only for the CM5 line, which does not have EMCC like integrated into the module. So if you are whether you are using CM5 Lite or CM5 with the EMCC integrated, you should think about you are adding the SD card port or not. It depends on which version of the module you are using. And according to the module, you should design your own CM5 IO board. All right, I think this page is covered, but if you see any questions which I should answer regarding this page, you can put in comments and I can answer in the comment section. For right now, I am going to move into the last page of our schematic. So after this one, I think schematic is fully covered, and then we will go to the PCB design. In the last page, we got the PCI Express M.2 port. So in the M.2 port, let's start from the 3D. You can see here the M.2 P like M.2. Normally M.2 port comes with different sizes. Like you can see, they have added the mountain hall for each size here. It is very good. But if you are designing a CM5 IO board, and you know the sizes of the modules you are going to use. Let's say, for example, you are adding M.2 to at the SSD card, and then you know the size is which one, and then you do not change these small things, and you can save this some of the disk space. But if you are using a general one, like they have it is better to have the overflow uh, calls so that end user has the end user can use whatever the version they are going to use with your board. All right, now let's move to the schematic then. So in this schematic, M.2. So M.2 actually it's a PCIe expert signals we need for the M.2. So you can see the PCIe expert signals coming from the CM5 modules connected here, and the clock is connected here. Like the PCI expert reset, clock fixed, and the wake up pins are connected, and 3 point like M.2, these modules use 3.3 volt and they take some kind of not small power, like I mean, some devices take up to 1 ampere, 2 ampere power. So we can't directly connect 3.3 output from the Raspberry Pi CM5 to this PCI Express M.2 because we do not normally M.2 port require more power. What happened? We directly connect this one. I'm talking about this output. So we have 3.3 volt output here, but it is limited to 600 milliampere. So if you can use the same 3.3 volt for the M.2, what happen is when you connect the M.2 device, system may go crash, and so everything is stop work or something happens. So what they have done is they have added extra, let me zoom in properly, extra buck converter here. So buck converter input is 5 volt from the type C here, and we have pin to control like we enable and disable the 3.3 volt, which is very good, very useful in saving the power because if whenever you are not using M.2 board, there is no point of keeping this buck converter turned on and generating 3.3 volt at the output. So this pin is handy. This one the signal is handy to turn on and off 3.3 volt for the M.2 board whenever needed. And we have 3.3 volt here. And it is also important to use a buck converter instead of a linear regulator in this case because the output current 3.3 volt at the 3.3 volt is not like a few milliampere. It's like 1 ampere, it can be 1 ampere, 2 ampere. So in that case, if you use a linear regulator, what happens is the total power loss or total efficiency goes down. The power loss is high and will generate a lot of heat if you are using a linear regulator. So it is very important in this case, in here for the M.2 port, you use this same buck converter circuit or similar buck converter circuit, but do not use a linear regulator. That is my advice. All right. Then another thing, and the very cool thing we got is the this oscillator here. This clock, like this signal, which is called SAS clock, is referred to as suspended clock. Is This pin is used to like uh, for the power saving kind of things. Like this signal can be used as a reference signal in sleep mode for the M.2 modules to like sleep into a certain time and wake up whenever needed. So it's depend you need that features or not. But when you are designing your own board, you can either remove this one or add this one. It depend on whether you use this feature or not in the two devices. All right. I think regarding the end of two also I covered everything, and now I'm going back to the road trip, and you can see I discussed about Type-C power input port, and then we discuss about the high speed. Here we discuss about HDMI, like CSI, USB Type 3, we covered there. And after that, we came into the GPIO stage, and here we discuss about the Ethernet, SD card, and 40-way Raspberry Pi GPIOs, jumpers, fan, and battery. We discuss about all of these. Then we discuss about the M.2 port, and here we discuss about the some power side as well. One important thing I forgot about M.2 is I'm going to now discuss. So you can see with M.2, so in M.2, this M.2 port has PCI Express signal. And some M.2 devices such as, so let me find out, Circuitry and the two model. And, let's GCR picture. Something like this. I saw it's a right model by the way. We need a kind of a network model. So, um, yeah, let's say for example this one. So this is a 5G. Let's say you need to use the 5G with CM5. Like so, we can use that MD is calling in that form factor. So what you can do is you can plug that module here, and it's M.2 form factor. And what happens is uh, this M.2 does not have that SIM signal, so kind of SIM interface. Because although you plug 4G, 5G network module, they need a SIM card. So this board does not have SIM card or kind of thing. So if you are willing to modify your own board to work with the network module such as 5G module, then you should think about customizing it with M.2 port and adding that SIM card interface as well. That is one thing to remember. Like this one straight away will not work with the 5G, 4G model. All right. Now I think I have covered. Yeah, this is the topic I want to cover in the last. And then I'm going to the next slide. Now I'm going to the PCB design of the board and discuss some important things which are helpful in your own design. So going to the PCB design, and this is the overview, and some of those are very much experience. Uh, let's turn on your video sensing. This is how. So first we will look at the 3D view and get an idea about it works. Uh, this is how it looks like. But you will definitely need a different layout when you are you design your own PCB design. and maybe you want to reduce the size, you want to customize the locations, you want to remove some components, you want to add some components. So, but this file, like this design is a good starting point. So, first, I will come into the some important things we have to consider when we are designing our own CM5 IO board based on this. So first thing, that very important thing is the PCB data. So what is this data? Actually, this is whole layer board. So here you can see this page shows the PCB data. So this board is a four layer board. So you know, four layer board is costly than two layer PCB board. However, in this particular case, for the IO board for the CM5, you can't use two layers because this board has lot of high speed signal. For example, these SDMI signals coming from module to here are high speed signal. These signals are carrying a lot of high speed data. So what happen is we should do the impedance matching for these signals. Otherwise, if impedance does not match, signal gets reflected for and at the receiver end, like let's say the power you transfer the data signal here, and at the receiver end you do not receive that power. I mean the reflection or like when the impedance is not matched properly, the signal is not transmitted to the other end properly. So in order to do the impedance matching, let's say for example for this PMI, we need to match this impedance to the 100 ohm. To match the 100 ohm, we can't, actually it is not practical to do with the two layer. So at least we need four layers. Actually four layers structure. So if you are not much familiar about that, what you can do is you can use the same setup and same setting as they have used. Let's say, for example, here if you go to the net classes of the TCAD, you can see they have already defined the differential pair width and gap for each impedance. Like for example, 100 ohms, 50 ohms, 75 ohms, 90 ohms, 90 ohms for USB, and HDMI, they have already defined it. What you can do is you can use the same net classes and without worrying about much. And but you should inform your PCB manufacturer that you did those calculations based on the these setup settings, also listed here. So it is very important to inform your PCB manufacturer that you need the impedance control signal and you have calculated in such a way that with this setting, and then that PCB manufacturer will change their step up and match the impedance and then the manufacture the PCB. Otherwise, you may design the board, and once you get the board, it is not performing as this original board. It is because we stack up the layer stack up of your board, and the original board is bigger. And so this is very important thing to remember. Like important thing is the PCB stack up and impedance matching. And second thing, when you are designing your own PCBs, this is most important, very important thing, high speed signal routing. So if you have a closer look into this PCB, let's look at let's look at these two signals, uh, this one and this one. Do you think why this signal is going not going straight away like this? We could do like this. But what they have done is it is taking a longer path and coming back here. its signal is going straight away. It is because this TRB positive and TRB zero positive and TRB zero negative are differential pair. So the length of these two signals should be met. Otherwise, uh, it doesn't work the same way as we have said. If we connect like this is obviously longer than the now first is obviously longer than the second. So in order to prevent that, in order to get that extra length, what they have done is they have gone through a long route and come back. So now effective length of both is same. If you look at this again, TRB1 positive and TRB1 negative, they have done the same. You can see this signal is coming straight away as possible, and the second signal taking long to and coming back to here. It is to do the length. What they have done is to lengthen. So it is very important that when you are designing your own board, do the same. You should match the length. Otherwise, Ethernet will not perform as you expect. And again, the signals going from here to module should be also matched in the length. In this case, they are in the same length, so they haven't done anything to match. But if we look at here, can you see HDMI 0 negative and HDMI D0 positive? D0 positive here is taking some bends and increasing its length. So it is because this signal is slightly longer, like slightly longer than the D0 signal if it went straight away. So in order to match the length, what they have done is they have done like this. So it is very important to match the length. Also, it is important that it is another lesson I want to discuss, but I think the you should decide where these bins are taken. Like you can't do that with wherever you want. It is another lesson. I'm not going to explain much here, but it's you maybe research more about these things, and you will find out why I'm explaining. I say like that. All right. So high-speed signal routing, that is one thing I want to discuss about PCB. Other than that, like most of things related to very important thing is the high-speed signal. Because you should take care of those, otherwise the PCB, your customized board will not perform properly. And other than that, the PCB traces, like this trace, if you look at the trace width is very high because it is carrying high current. For the other signals like the data signal, you can use the traces with the very thin trace because they are not carrying current, they are just carrying the signal. Um, Other than that, I don't have much to discuss about the PCB design. Other things you can place as you want, but it is always better to like keep them organized. Like here, the power supply is here. No, it's not. Yeah, it is the power supply for M.2. So you can see everything related to M.2 is pretty much closer. Like that, it is good practice. Also, this ESD protection for the Ethernet, you can see here small two components. They should be placed closer to the Ethernet as possible. And then you can see here HDMI related components here. HDMI related components like HDMI power switch here, kind of things are packed there. Like it is always good to organize things like this in your design other than putting them everywhere on the board. It is good practice to do that. And that's all for the PCB, the advisors, recommendations that I have uh, regarding PCB design. And then I think for this video, okay, now I'm going into the last section, how to get customized code. Okay, this is a short section. Uh, at the end of the day, in this video, what we expectation is get a customized CM5 board based on your project. First, what you should do is before start design, you should design the requirement. Let's say, for example, you want to have two USB port and one HDMI port and no camera, no other display ports needed, and no M.2 port or no PCIe. So in that case, and obviously you need the power circuit. In this case, uh, you can remove a lot of these parts. So as we discussed, you only need two USB ports. Obviously, you may have to take this one uh, to download the image module. Or if you are using an external board to download the image module, maybe you can use this and you can remove this one and add the extra power inputs or something like that. And you can remove internet circuit completely. You only need one HDMI, so you can remove HDMI 1. You can remove this, you can remove this. It is better to keep this jumper or configure small, keep the pins you need and put into the small jumper and keep those pins accessible whenever you want them. And if you don't know GPI header, you can remove that. You can remove this PC battery and M.2 and get a compact board with only the things you need. So first thing is we decide the requirement. And sometimes you may need USB two USB port, but you do not need them to be USB Type C. So in that case, there is no point of using always Type 3 port is expensive than the Type 2 port. So there is no point of using the Type 3 or USB port in that case. So what you can do is you can stick with the USB 2 port, two USB port, but you are using Type 2 USB port. So like that, first you should decide your requirement and you list down the requirement and then you decide what are the things to remove and what are the things to add to this point. And that is the part two. You add and remove the circuitry as needed. In that case, you may need an experienced engineer or you can do some research in the internet and get some support and then do yourself. It depends on your experience and your skills. And after that, this should be done in the schematic, but it is always good. This files provided here in their website, this data file, it is always very good to start from there. Then finally, what you have to do is you remove the circuitry, you add the circuitry, and then you import that changes to the PCB, uh, and then you modify the PCB. Like you will have to read all the routing and everything. Most of the time, or you may keep some routines, like some routines they have done, but you will have to reorganize the things and then modify the PCB and start routing again. And finally, you can generate the manufacturing files like. Here, we can use this command to generate the global files and the positioning files, and also for the DOM, you can use DOM means bill of material. You can use this table, and I see the manufacturing part numbers are listed. Most of manufacturing part numbers are listed. So. You can then submit those files to the PCB manufacturer. And important thing, you do not forget to mention that you need the impedance control PCB because this PCB is not a simple PCB, it is a high speed, it includes high speed signal. then you should manufacture a impedance control PCB, otherwise it will not work as you expected as once you start to use it. So that's all about getting draw. Those are the things you should keep in mind when you are modifying this board and generating, like designing your own board. And if you have any further questions regarding this design or this schematic or this PCB, you can contact me or you can submit, you can put a comment and I will try to answer as possible. Mm, that's all for today. And I think if you have anything to further discuss, it or you can put in the comments, and then I will answer as possible, and I will try to bring more videos to you, which should be. I think these videos are very helpful for people who are very interested in electronics and designing circuits like it. And I hope to keep doing this. More videos for you people, well, you guys. And thanks for watching this video. And if you can subscribe the video, subscribe the channel, and also put some comments regarding your questions, your thoughts, which will be very helpful and very, which will be very beneficial for me. Like if you put some comments and what you think about the video, or what you think about what you think I should improve in my videos kind of thing. Finally, again, thanks for watching and stay tuned. And I will come back with another great video. Thanks. Bye bye.